All right, so what we're going to look at today is a particular example of a differential equation. Now, this one is a particularly important one, and this one is the logistic equation or the logistic differential equation. So what we're looking at here is how organisms might grow, how they might expand in a habitat. Now, we could very simply think that the population of this individual, and it could be population of bunny rabbits or cane toads or virus or all sorts of things. We could think of it, how it changes in time, might just be some constant times the population. So this is a proportional to the population. So that's saying the more population there are, the quicker it will grow because there's more of them to have babies. However, this is a little bit simplistic view because this will imply that it will continue to grow faster and faster the longer you go, and there's no upper limit. But any of those organisms are going to eventually run out of food, or maybe they'll run out of nesting spots, or they'll run out of something. There'll be something that reduces them. So we talk about with the logistic equation having another factor in here, which is reduces the speed when it gets towards the carrying capacity. So we want to put something in here that will slow down as you get towards some kind of maximum limit. And if we had something minus a p, then when we multiply this out, we'll have this getting bigger, but this will be getting smaller. Okay, and it will get to 0 at the point that reaches whatever this carrying capacity is, and so the increase will be slower. Now, when we looked at this k before, we tend to no longer use k when we're talking about the logistic equation. We'll use r, which is a reproductive capacity. And K we use as our carrying capacity. And rather than putting it here, I'm going to do 1p over K. Effectively, if I times through by K, I'll just have this K coming out the front, but I'd have this K minus P there, so that would work. Okay, so this is our general equation. Now we might have a look at an example of how we go about actually integrating that, how we solve that differential equation, and then get a solution from it. I'll do that in the next video.